Hello friends, welcome back. In this video, we will cover the top interview questions for .NET Core and the Web API, complete with concise answers to help you prepare effectively. Whether you're a seasoned developer or new to the field, these insights will equip you for next job interview. So without delay, come let's get started. Alright, so before I go through some important questions, this is not a regular interview questions video where you have some questions and then you have a typical answers. No, I'm going to give you really very important concepts that can be asked, and questions can be framed in whatever way they want, right? But the concept is what is important. So we will focus only on important concepts, the way how interviewer is going to ask you the questions. Alright, so the first and important concept is somebody is going to ask you about implementing dependency injection in .NET Core Web API. So your answers could be like this. DI is already built into the .NET Core and can be configured in startup.cs using the configure service method. Now, the follow-up question could be, okay, fine, what kind of lifetime that can be registered? If they ask you, then the answer is services can be registered with lifetime like 3 types, like transient, scoped, and singleton. Transient creates new instance per request every single time that your constructor or anywhere that you are asking for instance. The transient type will give you a new instance. Scoped is per HTTP request, and singleton is shares the same instance of the application lifetime. Okay, this is very important. So there are one question and there is a follow-up question in this concept. Now let's quickly take a look at the real example, right? So if you go to program.cs with the .NET Core 8 or maybe 6 and above, there is no concept called configure service. Instead, the concept is same, but there is no special method like that. So these days we have just the main method. Okay, the place where you will inject or you will configure the DI is when you say builder. So here is the builder, right? So we say web application or create builder, and then we create an instance of that builder. So builder.service, that is where you configure your service. And then now builder.service, you see this dot add scope, that is the follow-up question that what we were talking about. There are 3 types: transient, you see this transient, scoped, and singleton. In my application I don't have singleton instance, but that's the 3 type. So you will configure builder.services dot add scoped or add transient or add singleton. So that's what it is. It's in the program.cs, not the startup.cs. Startup.cs is in the old way of writing, but these days it's directly in the program.cs under the main method. Alright, the next one is handling authentication and authorization in Web API. If they are asking you, how do you handle this authentication authorization? The simplest answer is, you'll be saying, I will use JWT token for the stateless authentication integrated with the Auth 2.0 or OpenID Connect. Okay, so this ASP.NET Core has a inbuilt support via Microsoft.ASP.NET Core.authentication.jwtbr. I will show you that in a moment, but we have a lot of applications that we developed which uses Azure AD B2C or Azure AD. Both deals with the JWT token, and the underlying frameworks are developed on top of the standards called Auth 2.0 and OpenID Connect. Okay, so that's what the answer is. I will give you all of these details so that you can prepare, but the concept is you need to understand what they meant to ask you and what you're supposed to answer. That's what the intention of this video. Now, this could be a follow-up question, what is JWT? I have a separate video talking about the JWT and how it is used, but in short, if I have to tell you, JWT is basically a compact, lightweight string kind of thing, which will have 3 types: header, payload, and signature, which is having all of this information which is sent in every request to the server, and server will be able to validate and treat you how you wanted to be treated based on your privileges. Okay, let's say your roles and other stuff, right? So that's how this is built. Now let's talk about this configuration of this JWT. Again, our application deals with Azure AD B2C. Doesn't matter whether it is AD B2C or identity server or Azure AD or B2B, whatever it is, right? The concept is same. So if you come to this program.cs, we have something like the configuration here. Look at this, builder.service, add authentication, and then you're saying the JWT bearer token dot authentication schema. This is where we will configure the authentication, and that deals with the JWT token. Okay, let's move on to the next one. What is middleware in .NET Core? So if they are talking about middleware, this is basically an important question. So let's understand. Middleware components are used to handle request and response in the request pipeline. I will show you in the code. You can create custom middlewares by implementing invoke or invoke async in a class and adding it via app.useMiddleware and then give the name. This is how you use, right? So middleware also executes sequentially and the order matters. Each piece passes the request to the next. Let's understand in the code. Again, we are in the same program.cs, and if you come all the way through down, after you configure all of these services, there is something called middlewares. So builder.build will get an instance of this app dot anything that you put, that's all called middleware. For example, use course is the middleware inbuilt by the Microsoft. Use exception handler is a middleware. All of these things that you see, it's middleware. But if you look at this is custom middleware. I created a middleware that we are talking about, right? So it gets the request delegate. You need to implement the invoke HTTP concept, and you just need to invoke it, and then you just pass on to it. All right, so this is called custom middleware. So basically app.use middleware, and then if you put your custom middleware, that is how you developed, like you use the middleware. But if you're using the inbuilt middleware, you just say app dot the middleware name. Okay, all of these things are middleware. Now order matters. Why order matters is it's like this, right? Think of this. A request comes in like this, it comes here, and then it executes all of these things, okay, till here, and then once the request is finished, it will go in the reverse order. That is why order matters, and that's why it's called request pipeline. Like if a water flows inside a pipe, how it goes? It goes through where you pour the water, and then it goes all the way to the end of the pipe. That's it, right? Same thing. That's why it's called middleware pipelines. Okay, let's move on to the next one. Handling error, logging, and exception. So how do you handle error globally, right? Don't say try catch. Try catch is meant mainly for non-managed code. Like if you have control, you don't need to write the try catch every single time. It's like how much you will write. So don't say it like that, right? Try catch is a good answer, but it's not the right answer, in fact. Okay, so if they're talking about error logging and handling exceptions globally in web API, what you need to refer is this one. Again, come to the program.cs. We have an inbuilt error handling mechanism here. You see this? When the request goes through like this, it is registered. Okay, so that's why the order of the pipeline matters. This is in the second order. It is registered, and anything that goes wrong after this, including the controller call, it will be caught here and it will come here. We are logging here, and then we handle the error. Now, there are other concepts, like there are something like application insights in Azure. You can use that kind of a logging mechanism to track every single thing that's going on with your application into your application insights in Azure. So then you can, you can go through it and then find out a lot of information about how the application was, going through, and you can improve it better. There are other, error handling like logging mechanism like serilog, nlog. You can use any of those things for better, logging mechanisms. Okay, so next thing, model of role binding. So now the next one is the role of model binding and model validation in web API. So the answer could be they're asking about how the model binding is working. The answer is model binding automatically maps the HTTP request data to action parameters. Validation ensures that the input meets the defined rules using data annotations like required, max, minimum length, or even the custom validators. Custom validators are created by implementing iValidatable object or writing custom attributes, or you can also use the external packages. Now let's take a look at this. So let's say we have a controller. All right, so let's talk about this, right? Model binding. So we have a controller where we have a HTTP post method. So it expects the body to have this kind of a model. So whoever is sending will be sending these kind of information in the request body. As long as the property names matches, this model will be automatically binded. So model binding will happen automatically based on the incoming payload to map this properties, and then of course you'll have all the data, and then you'll be able to process. That's what called model binding. Now if you go inside this model, you see this, there is something called required, string length. These are called data annotation. This is how it will make sure that this topic property should be within 50 characters and it cannot be empty. If any of these two fails, it will reject automatically with 400 status code, which is called HTTP 400 status code, also called bad request. Bad request means client can always correct it and resend the request. That's what it called. Okay, so let's move on. What is implementing API versioning? Okay, so you might have seen a lot of videos in my channel that doesn't talks about API versioning. API versioning is very important. Let me give a very good example of a real-time application, right? So let's say there's an insurance company. Okay, insurance company don't deal with the only the website that they have. There are other external agents who will talk to their APIs to generate some information in their own portal. Because let's say in India there is something called policy bazaar, or forget India, in US also you might have some agent company which is also generating some insurance behalf of the insurance company, right? So what I'm trying to say is APIs are exposed for the external parties to consume it. Now, when there is a change in the underlying API information or the response, client, like the company who created the APIs, they don't change directly. If they change, what will happen? Think of this. Today, you have a house, you have a door that everybody knows where to come and open it. Now, you change the key of the door without telling the person who has the actual key. They cannot come inside that. Same thing will happen. If you change the existing API without informing the clients who's using those APIs, it will fail. There will be some drastic problems will happen. So that's why API versioning is coming into picture. So what API versioning will happen is you create a newer version of the existing API, like an improved or changes in the data model or the response or whatever it is, right? That will be named as V1, V2 or V3. It's called versioning of the APIs. So once you're done with that, they will be publishing these information to the consumers, like the agents. They will change whenever they wanted to change, and then eventually the older API will be retired. So that's what called API versioning. Okay, so versioning allows us to maintain backward compatibility while introducing changes to the current API. Okay, that's what called API versioning. What is the next one? Managing configuration and settings in ASP.NET Core. So in ASP.NET Core, you might have seen app settings.json, which will have their own stuff called development, production, staging, QA, all of those things. So if you look at this, app settings.json is there, and there's some specific settings for development, specific settings for production. This development, production, this is all named based on this setting. So if you go to launch settings, currently ASP.NET environment is set to end development. So when I run this application, this will be taken. Okay, now this is all fine for the locally developed application. However, there are something called configurations. You can also configure this in the Azure also. Like, and then coming back to this concept, right? Configuration is handled via app settings.json. That is what I just explained you, and can be injected using the I configuration. So there is something called I configuration, which will read every single property of this configuration, which is in the app settings.json. So you can inject the I configuration and you can start using the properties by in any of the controller or services. You can also store all of this information into the Azure Key Vault, and you can use that in the deployed version. All right. And one thing you should remember from .NET 6 Plus, these settings are automatically refreshed during the runtime. All right. What is CORS? Cross-origin resource sharing, and how it is enabled. I will explain you in the code, but basically cross-origin resource sharing is, let's say we have an application backend and the front end. Front end is hosted in one place. For example, all right, let's take an example. Okay, so this website is the front end application. Okay, and then this website, you see this URL, this is the URL, right? This is in one domain. And let's make a call. Okay, let's make a call like this, and there's an API call going, and look at this, the API calls request. Okay, so let's take a request. general information. You see this? Smart Learn by Karthik dash API. It's a different. These two are different. So whenever applications are hosted like this, which means cross-origin resource sharing, this origin is sharing information with this origin, which is different. Now, in order for the UI, like the one of the domain to talk to the different domain, this cross-origin resource sharing should be enabled in the .NET Core. Only then this will work. If not, it will give you an error called CORS, like CORS, CORS error you will see in the console application. Okay, so that won't allow, because that's by nature, by default, the settings for preventing security issues. Think of this, right? You have a website. You're trying to call from your website to my website data. Can I give you data without knowing who you are? No, I won't. I need to register that, okay, you are allowed to access my website. That's what the configuration is. And let's go to this example. Let's go to program.cs and let's go all the way to the configuration service. You see this? I'm configuring in the service. Builder.service add CORS. This is the inbuilt one. And I'm saying I have a policy named default, and I'm allowing only this origin and this origin to go through. If any other origin tries to call this API, it will be rejected. Once you configure this, you need to come to the middleware and then say use this CORS. That is what from the coding perspective. Alright, so you know what is CORS and how to enable it, you know. What is the difference between .NET Core and .NET Framework? Okay, it's all very old question. Basically, .NET Frameworks are very much Windows dependent. .NET Framework applications are mainly for legacy applications and meant only to run on Windows servers. Windows, everything is Windows. You cannot run any application that is developed in .NET Framework on a Linux or a Mac. You cannot do that. Now, the .NET Core is a cross-platform, faster and ideal for modern and cloud-based and containerized-based application. Okay, so that's where we use the .NET Core, because now you can containerize this application and host it in Windows, Linux, anywhere. You can do that. That's the beauty of this, and that should be the difference that you need to explain if somebody asks you this kind of very basic questions. Okay, they might also ask you what kind of repository or unit of work pattern that you're using. Basically, the simplest answer, if you have used Entity Framework, trust me, this is a very good answer. Entity Framework or Entity Framework Core by itself, it's a repository and unit of work pattern inbuilt. Okay, because it tracks the changes and then it commits everything at one shot. That's called unit of work. Okay, so EF Core itself is a repository and unit of work pattern. But let's understand, repository pattern abstracts the data access and unit of work manages the transaction consistency. In a web API, they help manage complex data operations and improve the testability. If they cross question you that is it okay for everything, the answer is basically the bigger application, the extra complexity will come into picture. Okay, so it all depends on the application and what you decide, but basically this is what the answer is. They ask you about asynchronous and synchronous programming .NET Core. That's very important. Synchronous codes means you start the code till end of the thing, the same thread is used. Okay, so the more the code is synchronous and the more workload or the more traffic comes into your website, your performance will be very bad. Okay, because all the other threads needs to wait. I have a separate video for explaining how the asynchronous programming works. Take a look at that one. But in short, this is the answer. Basically, asynchronous. So basically, this is the short answer. Synchronous code blocks the thread until the task is completed, right? While asynchronous code allows the thread to handle other tasks while waiting for it. Async is crucial for scalability in web APIs, especially when dealing with input-output bound operations like database calls or file storing, file reading, and all of those things are IO operations. Okay, that will consume time. You should be using the asynchronous operation. Now, to implement the async in web API, you basically use the async await keyword and return a task of T-type in your control methods or in any of your services. That will allow us to avoid thread blocking. Okay, we have a lot of asynchronous implementation in our throughout application, so feel free to take a look. But basically, this is what your short answer should be. Implementing caching in your web API. Basically, caching is, there are different way of implementing caching. Okay, if you're talking about caching, it's basically storing or a small amount of information. For example, let's say a website that deals with the static categories. You don't need to call that category endpoint every single time unless the data is changed. So the moment the category is called, you save it, like you cache it in the server, and whenever the consecutive request comes, you don't need to talk to the database to get the category. Instead, you send the information directly to the caller. That will improve the performance of the system. Okay, and caching can be done at the server level, which will consume the server memory, or in advanced level there's something called Redis cache or SQL Server caching. You can use any of those things, but in memory caching is fast but limited to a single server. Distributed caching works across multiple servers, good for cloud-based application. And response caching caches the entire HTTP response itself. So those are the different types of caching. Okay, so distributed caching and non-distributed caching means if you have a web application deployed in only one server, in-memory caching will work because the server will receive the request every single time. But distributed caching means the moment you have the same instance deployed in multiple servers, there will be a load balancer. We don't know load balancer where it will send. It will send to server A this time, next time it will send to the server B. Caching could have been done only in server A, not in server B. So that's why this Redis cache will come, which is mainly meant for the distributed caching. Alright. Now, we will talk about securing a web API with the HTTPS. See, HTTPS stands for Hypertext Transfer Protocol Secured. So you have talked about, like you might have heard about SSL certificate. So any data that is transmitted between the HTTPS, they're all securely encrypted with 164-bit encryption. Okay, so that's why HTTPS is always secure and it is encrypted. The communication between the client and the server is always encrypted. Okay, you can also use these kind of settings called use HTTPS redirection and add some certificate for the protection environment. Okay, so we should understand for access security, you can also say for access security, HSTS, HTTP strict transport security can be added by calling app.usehsts to enforce HTTPS and prevent the protocol downgrade attacks. Those kind of things can be avoided. So take a look at this. If somebody asks about the securities, you can easily talk about this. Okay, if also you've been questioned about the file uploads and how do you handle the large file data transfer and all in web API, basically you will use iForm file to get the information of the file in the controller. Then either you store it in the Azure Blob Storage and retrieve it whenever you want, instead of storing it in the server itself, because it will go away. So you can store those kind of files in the Azure Blob Storage. For the large file, chunking the upload can avoid memory overflow. Now, security concerns including the validating the type file size and all will help you to prevent the buffer overflow attack and limiting the upload size in the startup.cs. Okay, now let's talk about the next one. If they are talking about or asking you about the file uploads or how do you handle the large file transfer in a web API, the simplest answer is you use the iForm file that will allow us to get the file information in the controller, and then you can store that file securely, preferably in a cloud service like Azure Blob Storage. And for the large file, you should be able to chunking the upload can help the memory overflow issues. Now, in terms of security, you need to validate the file type. If the PDF is allowed, you allow only PDF, and if the PDF size can be only within 5 megabyte, allow only that. Okay, so those kind of configuration will help us to avoid unnecessary overflow attack, buffer overflow attack, and those configuration can be done in the startup.cs by using the max request body size. Okay, so those are the tips. We are talking about the Swagger. Swagger is basically a documentation. It's a tool to document, test, and interact with API. So in .NET Core, I use the Swasbuck package to integrate the Swagger UI for the auto-generating API documentation, right? So that will help us to understand, and you can even customize this by accepting the JWT token in the Swagger itself. Okay, so that will help the developers to understand and test the API in a better and faster way. Alright guys, so these are the very top important questions or the concepts that they can ask you. So I've explained you everything. If you like this or if you have any questions, do write it in the comment section. And if you have not subscribed, subscribe to my channel and give me a thumbs up, and I will see you in the next interesting video. Bye bye. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more tech tutorials. And don't forget to hit the bell icon to get notified when we post new videos. If you have any questions or suggestions, leave them in the comments below. Happy coding!